When you create a volume in a computer, you must choose between two partitioning schemes: Master Boot Record, or MBR, and GUID Partition Table, or GPT. MBR contains the partition table for a disk and the master boot code. It's created during the initial partitioning process. MBR disks allow for 4 partition entries on a single disk. Windows requires an MBR partition system to start up from. MBR disks are compatible both with BIOS and UEFI. There's an upper limit of 2 TB per partition, but MBR offers no redundancy. With GPT disks, they can contain more robust partition entries, compatible also with BIOS and UEFI. However, Windows cannot start from a GPT disk using BIOS. Windows 10 supports startup from GPT on UEFI-based computers, which these days is probably most of them. GPT disks support up to 128 partitions. They also support 18 exabyte volume sizes, although Windows itself is limited to 256 terabytes. GPT is not available on removable drives, and does provide for redundancy. You're prompted to initialize the disk when you first install it in Windows, and at that point you can configure it either as an MBR or GPT disk type. Volume is used to arrange areas on a disk. Generally speaking, most Windows 10 computers have a single physical disk installed. That's not including external devices which you might subsequently add, or removable drives such as USB memory sticks. So taking a laptop, it will typically have a single SSD disk. Usually for Windows 10 that's partitioned into several volumes, one of which is the startup volume, often referred to as the system volume, and one of which is used to enable recovery, and another of which is used to support BitLocker and other features. All of this partitioning, all of these volumes, are created automatically during the installation process. But if you add a new physical disk to a Windows 10 device, you can choose how to partition the device and how to create volumes to support file systems. You can choose between a number of different volume types. A simple volume, as the name suggests, is a contiguous, unallocated area of physical hard disk that you can format with a supported file system. You can then assign it a drive letter or mount it into the file system into an existing folder. Simple volumes reside on a single disk, either in one contiguous block or in multiple regions. They don't provide for any fault tolerance, and the volume input-output performance is comparable to the disk input-output performance. A spanned volume, on the other hand, creates a join across unallocated spaces on at least 2 disks and up to 32 disks, and presents this to the operating system as a single logical disk. Because Windows 10 manages the spanned volume, you must be able to boot to the operating system to access the data on the drive. Spanned volumes provide no protection against a disk failure. All data will be unavailable from the remaining disk and will need to be recovered from a backup. There's also no performance benefit in using a spanned volume. They're predominantly used to provide volume expansion capacity, such as when a replacement of the drive with a larger unit is not possible. A mirrored volume uses 2 disks and presents them to Windows 10 as a single logical volume. The data on each disk is an identical copy of the other, and therefore provides redundancy and fault tolerance if a single disk fails. Sometimes mirrored volumes are referred to as RAID 1. To create a mirrored volume, you must use equal-sized areas of unallocated space from 2 disks, and, after you establish the mirror, you cannot modify or resize the mirrored volume. If one of the mirrored drives fails and is replaced, you must repair the mirrored volume, which then recreates the data on the new drive and re-establishes the data redundancy. Historically, a user could stripe data between 2 volumes on separate hard disks to achieve improved write performance by writing data in stripes cyclically across the disks. This is referred to as RAID 0, and is created from equal-sized areas of unallocated space from multiple disks. After you create a striped disk in this way, you cannot extend or shrink the volume. RAID 5 requires at least 3 disks and provides striped volumes with fault tolerance by adding parity information to each volume. It's not possible to create software-based RAID 5 within Windows 10. When you create a volume, you must format it using a file system. You can choose between NTFS, REFS, exFAT, FAT32 and FAT. Let's talk a bit about FAT for a moment. All of these file systems are compatible with other operating systems. So it's a very common file system to choose for removable media. It offers that compatibility factor. You can format your memory stick and know that you can use it in another device that's not necessarily running Windows. The same can't be said for NTFS or REFS. However, both of those provide the features necessary to run an enterprise operating system like Windows 10. NTFS supports file-level compression, so you can individually compress specific files and folders. It supports per-user volume quotas, so for an individual user you can specify how much disk space they can consume on an NTFS volume. Symbolic links and junction points are supported. Volume size is up to 256 terabytes. A maximum file size of 16 terabytes. File names and total path size is limited to 255 characters. Encryption is supported on a file and folder basis. There is transactional logging to help for recovery. And there are some self-healing capabilities built into the file system. NTFS is probably the default file system to choose, certainly for your system volume, and usually for most other volumes unless you have a specific requirement for additional features that REFS offers. Windows 10 includes support for the new file system called Resilient File System, or REFS. This was introduced with Windows Server 2012 and Windows 8.1. It's been designed to respond to the increased scale, access speed, and distributed nature of storage currently available. At present, REFS is not intended to replace NTFS, but does offer benefits to users such as storage stability, flexibility, scalability, and availability. It supports a transactional write model, which offers protection against power failures. It provides for proactive repairing and self-healing, which helps detect corruptions and effect automatic repairs. It provides for improved data integrity by reducing disk corruption through checksums employed on metadata. There's improved availability and scalability through the support for very large volumes and datasets. It also supports long file names and file paths with a total path size of up to 32,768 characters. There are a number of ways you can manage disks and volumes. Windows 10 provides the following disk management tools: the Management Console Disk Management Snap-in, Windows PowerShell, and from the command line you can also use the DiskPart tool. The Disk Management Console Snap-in is the tool you'll probably use most frequently. It's simple to use and simple to navigate. At the top of the display you can see a list of the available volumes. As you see, they're all listed as being simple. It also indicates their status and capacity and free space. At the bottom of the display you can see a list of the available disks, disk 0 and disk 1. One is shown as being a basic disk online, and the second is shown as being removable and online. In a given disk, each of the partitions are shown. And likewise on disk 1, a single simple volume. You'll probably use this tool most frequently to manage your disks. You can also use Windows PowerShell to manage your disks and volumes. The getDisk commandlet returns one or more disks visible to the operating system. ClearDisk cleans a disk by removing all partition information and placing it in an uninitialized state, erasing all data on the disk. Initialize disk initializes a raw disk for the first time usage, enabling the disk to be formatted and used to store data. SetDisk updates the physical disk on the system with attributes. GetVolume gets the specified volume object, or all volume objects if no filters provided. FormatVolume formats one or more existing volumes or a new volume on an existing partition. GetPartition returns a list of all partition objects visible on all disks, or optionally a filtered list using specified parameters. For example, this command resizes a partition on disk number 0 to 30 GB. This command retrieves disk 0. This command creates a new partition. It specifies the size and the disk number to use. The symbol over here on the right passes the result of one command to the next. That's the way Windows PowerShell works. So we've specified a new partition using a maximum size on a disk 0, and then we're going to format a volume using the NTFS file system, and then we're going to call this simple. This command retrieves information about a partition on disk 0. This command then creates information on that partition. Set partition, disk 0, partition number, whatever that number is, and a new drive letter. So we're using the set partition command here to specify a new drive letter for that particular partition. Although Windows PowerShell is the preferred method for managing disks and volumes and partitions from the command line, you can also use the DiskPart tool from an elevated command prompt.